So if you are able to see screen, the unit name is design against fluctuating load. So we are going to see how we are going to design. That is how we are going to find out the dimensions against the fluctuating load. Now, whatever may be the design which we have done for lever, then for joints, that we have done against the static load. It was not fluctuating. It is designed against the static load. So before proceeding, can you just give me difference between what static and fluctuating, that is dynamic? Dynamic, you can say it as a dynamic also. Basically, fluctuating name has given as it gets fluctuate, but with respect to time as it is fluctuating, that's why it is basically dynamic. So based on the static and dynamic, we have two categories of load, or we can say force also. So can you explain me what static and what is dynamic? All these things we are learned in first year only, that is in applied mechanics. So what do you mean by static?
Static means load is constant and therefore stress value is also constant, and
Load is
opposite
constant,
for a fluctuating load.
opposite for the fluctuating load. Anybody else who can contribute again?
An entity which remains
So
constant during
static
the
means
One by
is
one, you
called
can.
a static.
The entity which remains constant with respect to time is called as
Static.
static. Yes. And what about
And
dynamic?
uh, the entity which changes with time is called a dynamic,
Is called as
fluctuating.
dynamic. Yes, yes, yes. Somebody else was also trying to say something. Deshpande. Samruddhi Deshpande. Hello?
hello sir.
Yes.
We study the forces. Hello.
Yeah, we are listening you.
In static, we study the forces like acting on. Uh,
Yes.
hello.
Yeah, we are listening. Static. You explain it.
We study the forces which act on a uh, particular object stationary with respect to time.
Stationary with
And
respect.
dynamic means
Uh,
it is not constant
it is not constant with respect to time.
with respect to time.
Yeah. So everybody else has to be understood that the static means when we are going to apply that quantity, entity, you can say, that is going to remain constant forever the time. Whereas if we are going to get the change in that entity or quantity, then we are going to say it is dynamic. And as we are mechanical engineers and we are dealing with the forces, so these forces with respect to time, if they are going to get changed, we are going to put them in the dynamic category. Whereas if the forces are not changing with respect to time, then we are going to put them into static quantity or static category. So what we can say, it is related to the forces. That's why I'm talking about the force. It may be other quantity, like what we can say, that quantities which are not going to change with respect to time. It may be motion, it may be velocity, it may be uh, acceleration also. But one can say, if we are not going to have motion and that if the motion is not going to change, then definitely we are not going to get motion. For example, we can take motion of any building. So we are not having any relative motion of the building with respect to earth, we can say. Okay, if you are going to consider the total universe, then definitely we are going to have some motion because we are rotating with respect to or with Earth to Sun, and again whole galaxy is going to rotate. We are talking about the times which are on this Earth. Even we are not going to take reference of any other planet also. So when we are going to say that motion of any building with respect to some stationary object like tree or something like that, then we are not going to get any motion. That's why I say as a motion. And if motion is not there, velocity will not be there. If velocity is not there, then the acceleration will not be there. That's why forget about these quantities, because these quantities are coming under the category of dynamic only. But when we are talking about the forces, most of the cases we are going to see all these things related to the forces. And based on that force, we are going to have the two categories. If we are going to study that forces which are changing with respect to time, basically the forces which are responsible to create motion, that forces are coming under the category of dynamic. Whereas the forces which are not changing with respect to time, that are called as a static forces. So all the design which we have seen of joint, that is knuckle joint, quarter joint, also of the levers, that we have considered that once the force is applied on that element, on that component, then it is going to remain constant. So if you are going to see that force after 10 hours, it is going to remain constant. And that's why the stress which has induced in it, that stress is nothing but the product of that externally applied load. So stress is equal to force upon cross-sectional area which is undergoing for that type of stress. So when we are going to consider that force is going to remain constant, that's why stress is going to remain constant. The area is not going to change, or rather we have designed that area not to be changed. That's why we are going to say that the stress is going to be remains constant with respect to time. So we are going to see it in the due time of our lecture. First of all, we will go this syllabus. Syllabus related to this unit is we are having some points which are described in the syllabus as a stress concentration and remedies, then fatigue failure, endurance limit, notch sensitivity, Goodman and Soderberg diagram, then modified Goodman diagram, design for finite and infinite life under the reverse and fluctuating stress. Out of that, we are going to have numerical treatment, that is where we have to solve some problems related to the design for finite and infinite life under the reverse and fluctuating stress. All other points which are there, that is Goodman diagram, modified Goodman diagram, Soderberg and Goodman diagram, related to that, all these concepts we have to use in the designing of any component for finite as well as for the infinite life. What is life and all that, that we are going to see. Then as we are going to have the assignment questions, and already I have provided you assignment booklet. So from that booklet, you have to solve questions, okay? And that questions number, just you can note down that question numbers. Do you have pen and paper with you? Hello?
Yes, sir.
Yeah. Can I start? Should I give question numbers? So you have to write question number 1, then question number 2, question number 5, question number 12, okay, before writing that 12 number question, you write Question number 3, 5 already I have told you. 11, 12 and 15. Have you noted?
Yes, sir.
Okay. So we'll move further. These are the assignment questions which already you are having that assignment booklet with you. From that booklet, you can just write down these questions in your assignment notebook. Right now, you don't have that notebook. Just you can write that questions on your plain paper or ruled paper, which may be available with you. Now, when we are going to see the title of this unit, this title is Design Against the Fluctuating Loads. Rather than we can say it as a design against fluctuating stress also, because loads are responsible to create stress and loads are nothing but the forces. So already you are knowing what is design. Design is nothing but it involves that large procedure which we have seen in first unit. Okay, imagination, then specific principles of physics, engineering techniques, and creativity. All these things are involved in the design. But we are concentrating mainly of finding the dimensions of any component. That we are going to say as a design. So already I have given meaning of this design uh, in first chapter. We have seen it what the design is and its procedure. Now second word is that fluctuating. That fluctuating is nothing but the changing with respect to time. Any quantity you can say fluctuating word we are using related to the force or load, but in general, if you are going to use the load or that word fluctuating, it means it is changing with respect to time. It fluctuates, okay, but it doesn't mean that once it gets changed, is not coming back to that where it from where it has been changed. It may be possible that it is coming back to point where it has been started, where from it has started the change. That we are going to call as a fluctuating. Otherwise, if suppose the load goes on increasing with respect to time, it is changing. Suppose I have started applying load from 1 Newton and it goes on increasing up to 100 Newton for 100 days. That means every day 1 Newton is going to increase. Yeah, definitely it is dynamic load because it is changing with respect to time. Time here I have not mentioned in the hours, I have mentioned in days. So if we are going to mention it in hours also, you can mention it in hours, minutes, seconds also, because one day is having 24 hours and you can multiply it by 60, it will become minutes. And if you are going to multiply it by again 60, it is going to become seconds. So it is changing with respect to time. That type of load we are not going to call as a fluctuating load. It is a gradually increasing load. So fluctuating means it is coming back to from where it has been started, okay, and may change its direction also. It may become reverse. That is the reverse meaning is that when we are going to have the tensile load, so it may become compressive with respect to time. From tensile to compressive, it may get fluctuate, or it may remain as a tensile, but its quantity is going to change. Suppose I am going to apply 10 kilonewton as a tensile load, it may change to 15 kilonewton, again it will go to the 10, again it will go to the 5 kilonewton, but remains as a tensile only. It will not go to the compressive. We'll see all these things in details. Here fluctuating is nothing but the change with respect to time, and loads are nothing but in our case for the designing in mechanical engineering we are going to say those who are creating the forces that we are going to call as a load, dead load, live load. These are the types of load. Again, if you go in detail, you'll find more types of loads are there. Applied forces, okay. Then the work which we are doing against the that external forces, that all we are going to consider as a load. You might have studied IC engine subject, or whether it is, yeah, already you have studied that IC engine. So load which is coming on the engine, or in day life also, we are going to use daily life that meaning of load. Don't take load. Load means actually basically you want to say that don't take tension. Okay, tension, again we are going to say as don't take stress on your brain. So we are going to use that word in our daily life also, load. But the load is basically which is responsible to create the force, and force which is responsible to create the stress. So it is interlinked with each other. Then central idea of this unit is that just we are going to see what is this fluctuating load, and um, whether we are suffering through such type of loads, that fluctuating loads, and if it is subjected to, our component is subjected to any fluctuating load, then how we can design that component, or how we can find out the dimensions of that component, whether some different theory has to be used for that. What actually happens when we are going to change that load with respect to time? If we are going to fluctuate that load, what will happen exactly? What the nature will be there for the stress? And if the stress is fluctuating again, then what will be the effect of that fluctuating stress on that component? Whether it will get fail, or it will sustain it, or the stress will sustain by that component which you are going to design, that we are going to see. Okay, so in all, this unit is related to the fluctuating, that is changing type of stress, and designing, that is finding out the dimensions of components which are undergoing such type of loads and stress. So this is about the central idea. Now, why basically this unit has been introduced in our subject? If can we omit this? That question may become in our mind. But this unit is very important as far as our design one subject is considered, because once you are able to design, that is finding out the dimension of a component which is undergoing for a continuously applied load, that is static load, then you will find that only static load is not coming on any machinery. Because machinery, when you are talking about the machinery, and when you are going to make the definition of that machinery, it is related to the reducing human efforts. And human efforts are nothing but the dynamic person. Am I right? If you are going to, you are not having any dynamic nature, or if we are not having emotion, then we are going to call it as a dead. So when you are talking about the human being, absolutely it is coming under the category of dynamic. It doesn't mean that you should have continuously got moving your hands and your legs, okay, or you have to think very fast, you have to grasp things very fast, or you have to do something always. It doesn't mean that, but live things are nothing but the dynamic things which are changing with respect to time. We are becoming old and old and old, or we can say, rather than considering old, okay, be positive. We are becoming young and young. So we are changing with respect to time. Every year we are becoming young. So that's why we can say human being is a dynamic thing. And if you are thinking about the reducing efforts of that human being, definitely it should be again dynamic. So machinery, when you are talking about the machinery, it is related to the dynamic things. For example, we can take bullock car is one type of machine, we can say, which is run by the bullock, but it is a machine, okay, which is reducing human efforts. And if that bullock car is not moving, then we are not going to say that it is fulfilling our function. Or likewise, from bullock car, we'll go to the automobile or these commercial cars. If they are not moving, then we are going to say that the car is dead. So when we are talking about every machinery, it has certain moving components. And when the moving components are coming into picture, definitely the exerted or applied force to create that motion, they may change their quantities. So that's why we are coming always across these fluctuating or changing loads. And hence, they are creating fluctuating stress also. So that's why it is not only necessary to understand what the design, finding out the dimensions against the static load, but it is very important as mechanical engineers. If you are dealing with the civil one, then it is quite easy that we are not dealing with the dynamic forces continuously. Once you are going to have some formulas which are related to the earthquake, even when you are going to make that design safe against the earthquake, and we know that earthquake is not a common phenomenon. Okay, for here in Maharashtra, if we are going to say, then earthquake is very rare to rare, and hence the constructions or the structures which are built by the civil engineers, they are just checking it for the earthquake, that we are going to say as a dynamic thing. But when we are talking about the mechanical components, mechanical machineries, mechanical structures which we are going to say, then always we have to think about the dynamic loads which are coming on that. And that's why I always say in my lecture that as compared to all other engineering, this mechanical engineering is toughest one. It doesn't mean that we cannot understand it. It means that only we have to concentrate on much more things than all other engineers. We have to take into account all the things which are related to the time, which are related to the force, and their variation also. So it becomes difficult when we are going to study the forces which are changing, which are in dynamic condition. So it will become more difficult rather than the forces which we can study in static condition. That's why uh, it is observed that 80% of the failure in machine components are due to fluctuating failures only. That is called as fatigue failure. And that failure is occurring well below than its ultimate or than its design limit. If you are going to say that ultimate tensile stress of any component is 100 megapascal, and if you consider it as a design tensile stress as a 50 megapascal by considering factor of safety as a 2, then the fatigue failure which is, or the failure which is occurring under the dynamic condition, it may be at 10 megapascal. That the stress by means of which the failure may occur is maybe 10 megapascal. That means it is well below that ultimate tensile stress. And what exactly happens? That component is going to fail at 10 megapascal only, or the component is going to fail under the stress of 10 Newton per millimeter square, whereas its limit is well above that, that is 100 Newton per millimeter square. So it is what we can say magic of that fluctuating type of stress, and that we are going to call as a fatigue failure, the failure which is occurring well below than its ultimate or design stress, and it which occurs suddenly without giving in any intimation. We have seen while we have conducted tensile stress or tensile test, at that time we have seen that the elongation take place. That means that component is going to give us idea that it is elongating, and if the elongation is going beyond the elastic limit, it is not going to fail at that time. Just elongation started above the elastic limit. So at that time we can say that component is going to get failed. So just we can stop the machinery and we can replace that component. But the fatigue type of failure is occurring without giving any intimation, without having any elongation in that component, or without creating some abnormal situations. It may get failed suddenly. That is called as fatigue failure, which is more dangerous. In that case, accident may happen. So we have to take care as designer that such type of situation may not be occur while a human being is using our product, our machinery. That's why we should design, we should understood what the fluctuating type of stresses are and what the fluctuating type of loads are which are responsible to create this particular type of failure. And if you are going to give confidence to that user that though it is fluctuating, it may not undergo to the fatigue type of failure. Suddenly it will not get failed, or it will get failed after some usage. We can say after 10 hours, after 100 hours, after 1 lakh hours, it will get failed. We cannot give the guarantee of this particular component after 100 hours. So after 100 hours, you have to stop this usage and you have to just replace it. That type of confidence we have to give to the customers, to the users. For example, we can say last year or last to last year, we have seen the incidents which has happened in Konkan, that one of the bridge gets collapsed, and due to that, accidents happens. Likewise, there are a number of bridges all over the India which are actually built by British East India Company. And today also our government is receiving some letters from that East India Company that this location, they are going to provide us location, and they are going to say that this bridge has completed its age. After this, you cannot use it. That means it is a limit, or it has a limited age, and after that we cannot use that. Why? Because again we are going to consider this example of bridge, because bridge design is coming under the category of this dynamic type of loading. Because uh, when we are talking about the load which is passing over the bridge, so at a time there may be two trucks or there may be one truck, and truck which is moving, it may create the dynamic type of load. So that type of loading is considered that beam of that bridges. So that is one example, that we are going to have some limited timing for any component, and we can say that after certain uses of that component, we have to just give intimation to the users that it may get failed at any time. Okay, we cannot give guarantee for that. So just you have to replace it. But we have to give confidence to the users that it will not undergo to the fatigue type of failure. Okay, though we are going to take all these cares, again some accidents are going to happen. Okay, due to some loose, what we can say, faults are there, and due to some abnormal conditions where the components or machineries are used. In that case, there may be chances that it may undergo to the fatigue failure, and that is not the, what we can say, um, the designer's fault. It is a fault of that user. If he is not going to follow all the instructions which are given by the designer, then designer is not responsible for that. That user is responsible for that. Okay, so that's why this unit is important, and we have to study in detail all related to the fluctuating loads and fluctuating stresses. Now, when we are going to learn this unit, then what we are going to understand from this unit? First of all, we are going to understand what the fluctuating load is. Then what are the types of that fluctuating load? Then we are going to understand what the stress concentration is. Because while we are going to study this fluctuating type of load, we have to consider that stress concentration, that is the concept. What is its effect? And what are the remedies for overcoming that stress concentration? Now, you might have understood stress and concentration. Concentration is nothing but focused or gathered at one point. So that we are going to call, if the stress is going to gather at one point, if the stress is collected at one point, that is nothing but its value will get increased. That is called as concentration, stress concentration. And likewise, we are going to have concentrated acids. Then same way, concentration or concentrated stress is there, which may be more dangerous than the distributed stress. Okay, so that we are going to learn. Then we are going to overcome all these things, that is stress concentration and fluctuating type of loads and stress, and we are going to design the component against this fluctuating load and fluctuating stresses. That all things, or these three things, we will learn from this unit. Hope that I have make some sense, and you might have understood all the things which are related to this unit. If you have any question, you are free to ask. I'll take some pause here and allow you to have some questions. You can ask queries. Hello, are you there? Are you listening me?
Yes, sir.
Okay. So have you understood all related to the unit which we are going to learn, or you have some question? You are free to ask. You can just text in that message box. Hello. If not, we can go further. Should we continue? Hello.
Yes, sir. You can proceed.
Okay, I will proceed. So first point which we are going to see from this unit is fluctuating loads. Now I'm going to talk much more on this fluctuating type of loads, and I'm going to ask some questions also related to that to anyone who is attending this class. Akash Mane, are you there?
Yes, sir. Yes,
Okay.
sir.
Okay, do you have any query related to the things which we have seen?
No, sir.
No. Shall we move further? Shall we move further, Akash?
Yes, sir.
Okay. So first point which we are going to see is the fluctuating loads. Right now, all the things which we have talked related to the fluctuating loads only. Now, these fluctuating loads are nothing but the basically you keep in mind that these loads are nothing but the quantities which are responsible to create force. So we cannot differentiate these loads from the forces. We are dealing with forces only. Okay. So load is the what we can say parallel word for the force. So we can say it as a fluctuating force. So fluctuating force or fluctuating load is nothing but the load which is changing its quantity and nature also we can say. Nature means I am talking about if it is tensile one, it may change to the compression. So that's why I'm call it as a nature. So load or force which is changing its nature or quantity, we can say both. That type of loads or forces are called as fluctuating type of forces. Again, this change is measured with respect to time because all the quantities which we are going to measure, all the changes which we are going to measure are measured with respect to time. That's why the load which is changing its quantity or nature with respect to time, that load, that type of force is called as fluctuating type of load or fluctuating type of force. Now, again, we can have some categories of this fluctuating type of load. Out of that, first category is called as reverted force or reverted type of load. Here I have written as a stress. It is a load or force basically. And we are going to have same definitions for the stress also and for the load also. So this reverted, that is nothing but the forces or loads which are vary from 0 to its certain limit, that is certain maximum value. They are called as reverted. They are not going to become, they are not going to change their uh, direction. They are not going to change their nature. Once you are going to apply tensile load, suppose I am going to apply tensile load of 10 kilonewton, and if I am going to start it from 0, then I'm going to apply to its up to its maximum value, that is 10 kilonewton. Then again it will come back by 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. Again it will go to the up to 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it has to be passed while we cannot jump up to 10. It has to be passed through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Likewise, we cannot apply such type of load which exactly jumps from 0 to 10. It has a different category. Okay. So we can say that the load is going to change with respect to time. And within very short time, if it is changing, then we are going to call it as a jerk. Like we can take example of hammering. Hammering is again applying the dynamic load only. It may have the value from 0 to directly at 10 kilonewton within very short time. In that case, it is going to vary gradually if you are going to again make further dividation of time. But that time quantity is very less and we are going to neglect it. That's why we are going to call it as a directly jumping. But if that load is going to change gradually again with the measurable span of time, then again it is called as reverted load. But it will not going to go back and it will not change its direction. If it is tensile one, will remain tensile one. If it is compressive one, will remain compressive one only. Only it is going to become zero to its maximum value. That type of load is called as reverted type of load. We'll have one graph, and from this graph we can understood in better manner that what this reverted loads are. I'll draw here this graph. Is it visible? I'll make it visible. If suppose we are going to consider that this is the axis on which we are going to mention time. And this is the axis over which we are going to mention load, its quantity. Rather than here, I will give name here. I'll say it as a force. Okay, and here where the junction of two axes is there, that we will say as a 0. So can you, anybody of you, give me answer? What do you mean by negative force? Because here we can say positive one and negative one also.
Compressive force.
Right. It is going to change its nature. If we are going to say this as a positive side, I'll write here as a positive side. And same way we can say it as a negative side also. So below 0, we are going to have negative side. This is negative. But for force, we cannot say it as a positive or negative. Only thing is that it is with respect to something. It is force and is going to create its effect. It is going to generate the stress. It is going to create the stress. For example, I'm going to take only example. Okay, don't take it in other way. If we are going to have force which is applied, that is, if the boxer is going to apply force on the person who is in the opposite, what we can party, on head of that other boxer, then it is he is going to apply force and he is going to create the effect, right? But if you are going to pull in wrestling, it happens normally. If you are going to pull hand or leg of any other person, it is going to create the tensile type of stress, right? But effect is going to remain same. Ultimately, pains are there for that person who is going to sustain it. Though you are going to apply compressive one or tensile one, pains are there. Okay, so force is going to create its effect. It is not having any negative or positive type of what force. Only thing is that it is related one. That is, once you are going to say tensile as a positive, then compressive will automatically become negative because it has an opposite nature. And that's why we are going to say only it as a positive or negative. Hope you have understood it. Now, if suppose we are going to apply load in such a way that here, which starts from 0 is going some at maximum value, is coming back to the 0, is again going to go to some maximum value. This type of load, I'll make it visible. Okay. That means initially the component was not loaded or force is not applied on that component. But as the time passes, that time we can mention in seconds, as the time goes on vary, that load or that force is going to increase up to certain value, up to its limiting value. Always it is not necessary to have the same value. It may be maximum at certain point, or it may have it may cross that, and we have to take that value. If suppose here at this point, if it get increased, then we cannot use same as a value. This value we cannot use as a maximum one. We have to move further. We have to take this value as a maximum. Are you getting me? So we'll say that this is the maximum value that which we are going to consider. So this force is going to change from its 0 value to its maximum value. Then it here you can say it is not again. I'll enlarge this. Can I? I'll check, just check whether I can. So I'll take it on other slide. A new slide, I'll take it. So now it is visible. If it is going to change from its 0 value to maximum value, here you can say it is not reaching up to this line, but the value which you are going to take for the calculation is this value. Okay, so it's that just I want to mention that always it is not necessary to reach up to its maximum. So completely reverse, it is not completely reverse. So if it is reaching up to its maximum value, it is called as completely reverse thing. Okay, and this type of load you are going to call as a reverse type of loading, reverse type of forces, and the stresses which are induced because of this type of load is called as reverse stresses. Okay, and if it is going to become like this, that is nothing but from positive side it is changing to negative side. That is nothing but once if you are going to consider it as a tensile one, then it is going to become negative. This it is going to change its nature. It is going to become compressive. Though it is 0, then it is going to create compressive type of stresses. Here, this load is going to create tensile type of stress, and this load is going to create compressive type of stress. Right? So that is second type. And that reverse type, because we have to design the components against the reverse loading as well as alternating loading. That alternating loading is nothing but which vary from its minimum value to maximum value of positive nature. Positive, we have just mentioned that positive is and negative is not there. Compressive or tensile, we can say. Okay, that is from certain minimum compressive to certain maximum tensile, or from minimum tensile to maximum compressive, are called as alternating loads. Just now we have seen the example of this alternating loads, that is varying from tensile side to compressive side, that are called as alternative type of loads. Okay, then we are going to say the loads which are vary from one value of compressive to the same value of tensile. Now here we cannot have the freedom that we can change its value. How much compressive is there, that same amount should be there for the tensile, or whatever may be the tensile, that should have same amount for the compression. That is called as completely reversed or cyclic load. For example, on the same graph we can say here how much this compressive load is there, same amount should be there for. So I think I make it as the same to lower side and same to the upper side. So this value should be exactly replica of this value. Now it is not exactly same, so I will take this graph somewhat to the upper side, as I am not going to draw with scale, that's why this is problem. So these blue lines are having same quantity, then we are going to call it as a completely reversed. There is same amount of tensile load is there. We'll say this as a tensile slide. This is tensile side, and this is a compressive one. Okay, so it's compressive and tensile having same amount, that we are going to call as a completely reversed stress or completely reversed type of load. Any question? Here we are going to stop today. Hello? Do you have any question?
No, sir.
If you are having, you please ask. You don't bother about the time. I'm going to take presentation within 2 minutes only. Hmm? Are you hungry now? That's why I have to finish as early as possible. I'm going to take presentation, roll number 33, 31, roll number 1, 8. If I'm going to miss anyone, please let me know. Roll number up to 1, 3 is there. Whether the number is going to increase. Oh, it has increased up to 41.